Hello Internet, my name is Quinn and this is Blondihacks. We're back on the Coolman SU2 cutter grinder today. We're tackling the refurb of a very important part, the spindle. It's a pretty cool mechanism, you're going to love it. Let's go.
First we have to get the spindle out of the machine, and the only possibly relevant fastener that I can find is this set screw here, so clean the grit out of that and see if this guy will move. And it's very tight, very tight. See if it'll move. A little more love. There it goes. Alright, so now this guy will come out, and according to the parts diagram I have, the spindle is kind of a single unit that should slide out entirely. And, it hasn't moved in 40 years, so what are the odds I get lucky and it will? And, oh, well, look at that. I'm honestly very surprised by that. There's a hole in the back there that is presumably for a spindle lock, but it's just open, and I was able to use that to just give it a little nudge, and then out it comes. And there isn't even any rust on it, which is very surprising. The back of it is filthy because of that open hole for the spindle lock. But now let's see if we can get this guy apart. So once again, on the spindle unit itself, I don't find any fasteners. There are a couple of snap rings here, which I guess you'd call those fasteners. Is there a legal definition of fastener? I don't know. Anyway, so we'll take out that little inner snap ring there and clean all of this crud off of here, or some of it anyway. Absolutely everything on this thing is covered in grinding dust. And we can see there's a kind of a washer or a bushing of some sort underneath that small snap ring, so we'll take that out. And then there's a larger snap ring around the outside, and so we'll get this guy out of here. So now we get our first look at the bearings, and it looks like I might actually have those bearings. Why do I have a bearing like that? Because I recently converted an exercise machine from bushings to bearings, so I'll link to the blog post down below where I did that. If you've ever wondered what insanity looks like when manifested in the form of an exercise machine, you should check out my entire blog post series on that machine, in fact. I've gone to, let's say, pointlessly heroic lengths to keep it going for many, many years beyond its intended service life. Okay, but back to our spindle. So I've removed all the fasteners and nothing's coming apart, so it's pretty clear we have to press this thing apart. But the key is, where do we press and from which direction? If we don't do it right, we could destroy something. So the manual should be some help here. Unfortunately, the only documentation I have for this thing is the French version of the manual, and this is the manual for this exact machine from this time period. So it is correct in every respect, which is extremely valuable, but it's only in French. Et cela devrait être très formidable parce que je parle un peu de français, mais ma vocabulaire c'est trop faible pour les choses très techniques comme ça. Alors le document ici c'est trop difficile pour moi. But thanks to modern technology, we have a really amazing option. This, many of you will know, is the Google Translate app, and you can literally point your camera at text and it will translate it in real time. Now, I have spent a lifetime in software engineering and computer science, and I've done work in graphics and computer vision, and I am blown away by this. This is an amazing time to be alive. Honestly, this is fantastic. Now, as good as this is, however, the wording is just vague enough that I'm not 100% certain that I'm going to be doing this the right way. That key sentence is number 3 there. Using the spindle, press the spindle out, down. So what exactly did they mean by down, and which end of the spindle am I supposed to press on? That's not very clear. The thing we have working for us here is we can see from the parts diagram that there's a shoulder behind each of the bearings. So as long as we press them out one way or the other, the bearings will come out, and we might destroy these bearings in the process, but we don't care about these bearings because these are the old ones. So let's give it a go. Before we can do that, however, we need to get this pulley off. So I've got my puller out here, and this is a ratcheting locking puller that doesn't drop the thing when you're done. So I'll link to this down in the description there. This is a great little unit. You can see how the arms lock in place. All right, so that pulley comes off quite easily. It was a pretty light press fit on there. You can see there's ribs in there that hold it in place with the light press. So let's clean some of this grit off of here and get a look at that bearing. Just make sure there isn't another snap ring or something in there. The worst thing we could do right now is press against a snap ring. Longtime viewers of my channel will know that I always use my bench vise for pressing jobs because I don't have an arbor press. But wait, what's that? Yes, thanks to my patrons, I was able to invest in an arbor press, which is essential for this job. So this is a Jet 2-ton press, and the build quality on it is okay, but it's going to do the job here just fine. Fortunately, one of the openings in the base was the exact right size to support the outer cylinder while allowing room for the bearing to pass through, and I put a piece of brass on the spindle nose so I don't damage it. And I crossed my fingers that I interpreted that French manual correctly, gave it a press, and out it came, just like that. That actually worked really well. It didn't require too much force, which is a good sign that you're doing it correctly. So now we get our first look at the spindle arbor itself, and it's looking pretty darn good. All right, so now we need to press that bearing out of there. So I've got a long piece of scrap in the back of the bearing there, and so I'm just lining this guy up on the press once again, and just using my piece of brass again just for a little bit of extra height there, and that guy presses out of there very nicely. And we can see that there's a bushing behind that guy as well, and this sort of thing is all very important for reassembly. And now we need to get the other bearing off the back end of the arbor, and so I've got my puller out again. This is the same puller. It has a 2-leg and a 3-leg option, and it is actually pulling on the inner race only there, so it doesn't damage the bearing, although this is the old bearing, so we don't care. Now we can get our first look at the bearings individually, and the one in the back is okay. It's not great, but the one in the front, holy cow, that thing is trashed. That is actually the worst bearing I have ever encountered. I'll hold this guy up to the microphone. Sounds like that time I filled a cement mixer with the bones of my enemies. Whew, what a racket that was, let me tell you. If we take a look at the surface of the bearing here, we can actually deduce what happened. This discoloration that runs down the center where the balls are touching, that's heat. So what's happened is this bearing has been overheated, boiled out the grease, and then subsequently trashed. So yeah, little surprises like this are why we're taking this machine all the way down and building it back up again. All right, so both bearings are toast, but through the magic of YouTube, I have 2 brand new ones from McMaster Carr, and I ordered the ABEC 3 version of these bearings, the more expensive option. These are completely sealed, and they should perform very, very nicely. So now I need to reassemble everything, but figuring out exactly how it's all supposed to go back together is a little tricky. So the first thing I did is clean up the bores, and the thing about bearings is that you either press them in from the inside or from the outside, never both, because you can't have pressing forces that span the races where the balls are, or the bearing will be damaged. So generally speaking, there's one end that'll be a slip fit, and after cleaning up I see that this end slides in like that, so I know that the bearing is going to be pressed onto the spindle and then slipped into the cylinder on that end. But the other end is a lot less clear, so I'm cleaning everything up with some Scotch-Brite here, and I'm going to take some measurements to try to figure out what's supposed to be a slip fit and what's supposed to be a press fit, so that I try to do everything in the right order. These bearings are intended for a 17mm shaft and a 35mm bore, so I'm going to take some measurements here. Forgive me, I don't actually have metric micrometers, so I'll be working in imperial. So an initial measurement with the telescoping gauges here shows a 1.3775 inches on that bore, which is 34.99 millimeters. So that seems like it's supposed to be a light press fit on the outer race. However, when I measure the arbor itself, I get 0.6695 inches, which is 17.005 millimeters. So also a press fit there. So it's almost certainly the outer race though that's supposed to be a slip, so I did some cleanup on that. I think there was a bit of a burr on that snap ring groove, and so after that cleanup I take an additional measurement, and now I've got 1.379 inches, which is 35.03 millimeters, so just a hair over, and that I feel much better about. So I'm going to press the bearing onto the shaft, and then it should slip into the bore. Next, I need to figure out my order of operations. So I'm clearly going to be pressing a bearing onto the nose and then sliding that into the bore there, into that cylinder, and that'll slip in. And then I should be able to press the bearing onto the back from the other side. And then we'll press the pulley back on. In order to do this pressing, I'm going to need a bushing of the exact right diameter. So I've got a piece of scrap here that happens to already have a center in it. So I'm going to turn this to size. Got some anchor lube on there. It's cold, so I've got the shop buttoned up. So I'm using anchor lube because it smokes less than traditional cutting oil does. And I'm just going to make a nice concentric outer diameter here and get it down to a diameter such that it's only pressing on the inner race of the bearing. That's important. All right, that looks good. And now I'm drilling out the center so that it will slip over the nose of the spindle. And I don't quite have the right drill size, so I drilled it out to 5/8, and then we're going to set up with the boring bar and bore it out to final dimension. And I had to set up my boring bar at a bit of an angle here because I need all the depth I can get, and the thick part of the boring bar is going to interfere. So by setting it at a bit of an angle like that, you can steal a little more length out of a boring bar than it's really supposed to be used for. And a little test fit on that bore, and that looks like it's going to work perfectly. It'll slip over the nose, but it's still going to press onto that bearing journal perfectly. And I'm going to put a chamfer on both those edges to make sure there's no burr that's going to interfere with our pressing. And now we can part it off. And Yahtzee. And then I flip that part around and I face the far end. I've got both ends faced nice and square so that the pressing force will be nice and square. And then of course chamfering that as well. So I got a piece of brass down there to protect the arbor, and I got my bearing on there and that pressing bushing that we just made. And we line everything up nice and square and then send it home. And that bearing slides on very, very nicely, which is a good sign. That means we did everything properly. And that spins nice and freely, so we haven't crushed anything. And luckily I didn't forget that this bushing goes back in there, and then the spindle nose assembly goes back in there, and that's a nice slip fit on that bore. And then we can put our diaphragm springs back in, and these guys serve to preload the bearings. And then once those guys are in, we can set up to press that rear bearing back in there. And the setup is very much the same. I got the brass on there. I'm going to set that up, and then I can set my bearing in place. And conveniently, we already made that pressing bushing for the other end, so I'll just bring that in here and... poop knuckles. Okay, plan B. I took the leftover scrap from making that pressing bushing and I bored it out, and we'll use that. It's got a little shoulder on the bottom there that's just the same size as the bearing race, and it's shorter, so I can use that guy to press this bearing home. Now this guy didn't have as much setup room as the spindle nose did, so it was a little harder to get it straight, and it did go a little bit crooked on me, so I had to kind of shift it to the side and push a little bit off center on it to straighten it back out again, and then it did finally slide home. So there was a couple of tense moments here pressing this guy on, but in the end we did get it done. And it did press into that outer bore with no problem, so I think our measuring and figuring was correct on the order of operations here. And after that first install, it's a little bit tight. I don't think it's spinning as freely as it should, so I put it back in the other way, and I gave it just a little bit of a nudge with the press, and that loosened things up, and now it spins very, very freely. Beautiful. And I can see that the grooves are clear for the snap rings that are going to go in that other end. So let's get those snap rings in there, and this is one of those examples of where it's really good to take notes, or in this case video. This snap ring is not actually flat. It's got these little tabs that curl, and it's important to get those curled tabs facing the right direction. They face away from the bearing. If you didn't do that right, something could go very wrong. So this is where it's really helpful to have a YouTube channel, because I'm videotaping everything I do, and so I can go back, and sometimes I look at my own videos frame by frame to see exactly how a particular part was supposed to go back together. And then that thin inner snap ring goes back in, and everything looks good, everything spins freely, and Bob's your uncle. So just for giggles, let's see what the runout is on this guy now that we've got it all reassembled. So I got it set up here with a half-thou indicator, and we'll give that guy a little spin, and as far as I can tell, the runout is 0. So pretty darn happy with that. And now I got to put the pulley back on, and this guy's quite a light press fit. It came off with a puller with very little resistance, so I'll just reuse one of those bushings and press this guy in. And if you're paying attention, you know what's about to happen. I'm going to run out of room on that bushing, so I needed about another extra inch or two, so I took off the plate in there and I put on a piece of scrap to take up the gap and used the taller bushing, and then was able to press that guy home. And yeah, you should really have the back of an arbor press secured, but this was a light press, so it didn't really need to be. All right, we're ready to slide this unit right back into the grinder there. That's the top casting from the grinder. So just line it back up with the set screw hole there and put our set screw back in and give that a little test spin. And that looks great. Now the last thing I want to deal with is the other hole, which does not have threads in it, and it's for a spindle lock of some sort, but it collects dust, as you saw by the back of the spindle when I took it out. So I took a rubber grommet and I cut the bottom lip off of it to make it kind of a plug, and then I just stuffed that guy in the hole. I may later at some point put some threads in that hole and maybe put in a screw-in plug, but for now this is going to keep the grinding dust out of there. All right, the spindle is back together, and that is going to do it for this episode. I hope you're enjoying the refurbishment of this grinder. Thank you very much for watching, and we'll see you next time.